welcome. It's awesome to have everybody here. This is going to be very high level, but don't worry. There's, I guess, hopefully we're going to dig into a lot of it over the next 7 weeks. We have a lot of reading material. We can answer questions. So if some of it seems too high level or too abstract, I think that's probably okay. Maybe for some other people it'll be sort of obvious. Also, this is obviously kind of our perspective on what blockchains are. You'll hear different kind of views from different people, and that's a great thing. And this is just kind of one view on it. So we're going to start. This is kind of a two-part talk. The first part is this kind of interesting, I think, data analysis project that that we did here at the firm. So people that have been in the space for a long time often talk about the different waves of crypto. And so the really old school people were sort of pre-2011 and before, sort of when Bitcoin was only among a very small group of people kind of known about. And then there was sort of this price wave that led to sort of more interest. And then 2013 happened, and there was another kind of price wave, and that led to more interest. And then 2017. And so we tried to kind of like look at that history and put some numbers behind it, and I thought I would share that with the group because maybe not everybody has that kind of full context. It's also helpful because right now, if you read a lot of the press, you'll see a lot of kind of negative stuff. The kind of sentiment is among some crowds is, there was this big run up in 2017, and then it's a crash, and it's all over, and it's like, it was a fad, et cetera. That's obviously not what we believe. This is reinforced by this chart, which is, if you haven't been in the space for a long time, looks like nothing happened and then a big price swing and then it kind of died. We're not saying prices are everything, but people sort of take this as a proxy for, the general kind of excitement level in the space. What we think, but actually the way this space works is there's just kind of this kind of flywheel between the prices, which do kind of generate interest and awareness and kind of social media activity. I bet you a lot of you, every time we meet with entrepreneurs, we always say, how did you get in this space? And almost invariably, it's either 2011, 2013, or 2017. Their friends were buying these things, and they started reading about it. But the price is like a hook, right? The price kind of got them into it, but then hopefully they didn't stay because of that, right? They weren't, I doubt many people here are in this just because they want to see the prices go up. They're here because they actually believe in the technology, right? So what we've come to see is that people come in, they because of whatever, they're trading or something, they start to get interested. Maybe they start following people on Twitter or Reddit. They start to have new ideas. Maybe that is reflected in kind of GitHub activity and other things. And then there's new startups that come around. And we did this data analysis, and this is some of the data that we had. So this is wave one. So this is 2010 through 2012, and you'll see what's interesting on the price thing is it's almost fractal-like, where each wave looks very similar to the last wave when you zoom in. For the OGs here, you'll remember the developer activity this is primarily the Bitcoin GitHub repo. Startup activity, you started to see things like, that's when Coinbase was started, and a lot of the Kraken, and I don't know exactly what year Bitmain, but I think a lot of the miners and wallets, et cetera, right? The Reddit activity, and this is mostly, we're using Reddit here, but it's sort of a proxy for other things, and you start to see like our Bitcoin, things like that. So that's wave one. Wave two, 2013, I kind of personally got interested around 2012, made our first investment in 2013. You had that big price run up, and then look, and what's interesting there is the developer activity really started to take off. Startup activity, social media activity, and the developer activity was sustained even when the price kind of dropped back down, right? And this is when I think of it as, so that first wave, the startups were kind of more, wallet, Bitcoin-related wallets, things like this. Here we have some icons on there to show, you had Ethereum, Monero. You started seeing people playing around with the kind of new blockchain, new layer one designs, kind of a wider kind of design space, I think. Each of these times, like kind of the design aperture kept widening. For those who've been in it, you kind of know this intuitively. Wave three, which is the recent one, a lot more. We just put some examples up there, but there's, I think 30, depending on, you can pick your favorite 20, 30 projects that kind of got started around that period. The developer activity, continued to go up. Let me put this all together now because the axes kept growing and you can't see it all, but like these things actually go up really significantly. In fact, here's sort of the even with the drop, the CAGR is a financial term, compounded annual growth rate. Even with the drop at the end here, you still had significant growth rates year over year for each of those categories. And so, we think of price as in most startup markets, price is a lagging indicator. We don't invest at Andreessen Horowitz, and we invest in plenty of things that don't even have revenue or business models for that matter. And then only like 10 years later do you like sell it or something. So normally we don't think of price as we think of it as a lagging indicator. In crypto, it's weird, right? It's different. Like because these assets have prices and they fluctuate around, and as a result, you get this what I kind of have been calling the price, price, interest, activity kind of feedback loop, where the price feeds back into the fundamentals. Basically, the way I think of it now is we've, in 2017-ish, planted a whole bunch of seeds which are now going to hopefully kind of bloom in the next year or two. And those we hope, will kind of drive another wave of innovation, which in turn will kind of in this flywheel create more interest, more ideas, and just continue to kind of generate a positive feedback loop like that. So this is our way of kind of trying to characterize, like whenever I talk to people that have been in the space for a long time, we always talk about the waves and the people outside of the space or more new to the space, sort of like, what are you talking about? And aren't you just focusing on price? And we're not focusing on price, we're focusing on interest and activity. So that's just kind of the historical context. And that was a fun project because I thought that was going to be the case, but we'd never actually done the data analysis. Eddie here, is Eddie here? Eddie's our data scientist. We finally have a data scientist. So this is a very detailed thing. At some point, we'll probably put all this data on GitHub or something. Okay, so let me talk about kind of, at least this is my own editorializing, how kind of I think about blockchains. You'll hear different views from different people. By the way, when I say blockchains, we're not blockchains, not Bitcoin people here. We think that architecture of like a blockchain with a token, it can be generalized to a lot of different applications. And this is kind of how we think about it. So my sort of broad view, I think you can take in the history of computing, right? You have the kind of early ideas behind computers developed pre-World War II, and then World War II really accelerates things. You have kind of the ENIAC and all that kind of stuff, and then you have these different eras, and it's pretty remarkable how regular these eras are. They're every 10 to 15 years. You had a new era. So you had mainframes, mini computers, PCs, internet, and then smartphones, right? And then we're now, I think of the real modern advent of the smartphone era as 2007, the iPhone. So we're 13 years into this cycle. And sort of the way I think about it is there's kind of three logical possibilities at this point. Either this is the end of computing, we're at the end of history, the iPhone is it. 400 years from now, people are using iPhones and Instagram, maybe. All right, that's where I'm not putting my bets. Another view is there's going to be one new thing, and it's VR or AR or self-driving cars or blockchains or whatever. I actually, my own view is that it's sort of all of the above. I think there's a whole bunch of really exciting things happening. A lot of these new devices are kind of AI powered. They're kind of taking advantage of two trends, the sort of Moore's law and the shrinking of computers. You can get a $2, Linux powered computer now, and you can get with Wi-Fi connectivity combined with AI, and you have all this kind of cool stuff happening on the device side, which I'm not going to talk about today, but it's very cool, and it will mean there's many more devices embedded throughout the world. And then there's blockchains, which I think of as a new type of computer. And why do I call it a computer? It's a computer in the literal sense for those who do computer science. If you look at a system like Ethereum, you have a way to store data, keep state, and you have a way to operate on that state. You have a programming language, right? Now, Bitcoin, is what I would call an application-specific computer. It's a computer sort of like a calculator or an Xbox or some other kind of computer where it could do general-purpose applications, but for the various design reasons, the designers decided to constrain that into a limited set of things. So this is how I like to define a blockchain. It's a virtual computer that runs on top of a network of physical computers. So a virtual computer, meaning Ethereum, if you're a developer writing Solidity, it appears from that perspective of a developer to be a single computer with a single memory space and a single instance computer. Of course, underneath, there's a network of physical computers. In the case of the current Ethereum, miners or validators. Bitcoin has miners. You have physical computers underneath. The key feature of this, like why would you want to run all of these things on these virtual computers on the network of physical computers? It's because by doing so, you can provide guarantees that the computer will continue to operate as designed. If you write Solidity code for Ethereum, you know that unless more than X% of the miners become evil, that code will continue to run as designed, right? So you're not dependent. Now you think about any other computer pre-blockchain. There are two models. Either you own the computer, you have a personal computer, you have a phone, or you're renting the computer, or you're literally renting it from AWS, or you're effectively renting it when you use Facebook and Google, right? But behind every computer outside of a blockchain, there is a person or organization who can change their mind, right? And so if I went up and said, I'm going to have, if Google went up, or Chris went up, or anyone went up and said, I'm going to have a new currency, and there's only going to be 21 million of them ever, right? Chris coins, Google coins, you name it, right? Why would you ever believe that? Because the person who controls the computer can change their mind. The whole interesting thing with the blockchain is it subverts the governance. The hardware is governed by software instead of the software being governed by hardware, right? And that lets the software make guarantees that users and developers and other network participants can trust in a way that they couldn't trust a traditional computer that in the end is just sort of being puppet mastered by a person who controls it, right? And so specifically, like in this case, I like to say, I'm always trying to think about simpler ways to explain this. And the phrase I like lately is computers that can make commitments. And so a computer, in the past, you couldn't really make a credible commitment, but now you can. And so like when you think about Bitcoin, what commitments is it making? It's making the commitment to only be 21 million Bitcoins as an example. Now that's not a sufficient condition for value, but it's a necessary condition for value. If you didn't have scarcity, you couldn't potentially ascribe value to it and believe it's sort of digital gold. You may or may not believe it, but you need that, right? And there's an interesting reason why the only examples of anything that ever kind of had store of value properties before Bitcoin were either government-backed, because people seem to believe that governments can make commitments, although that is interestingly very, depending on the interest rate of the government, like is the level of people believe the commitment, or in the natural world, scarcity of precious metals and things like this, right? But that's why you've never had a credible digital currency before, I think, is because you didn't have this architecture where you could truly make these commitments to things like scarcity, to protecting from double spends, to true, genuine ownership, et cetera, right? But the cool thing is, I think what people have realized over the last 5 years is you don't have to stop there. You can make commitments about other things. And we're just beginning to understand, and this is kind of one of the exciting things I think about why I wanted to have this school and have people think about it. Our feeling is this is an incredibly rich design space. We have a friend of ours, Balaji, who'll be talking here, Balaji Srinivasan. He has a idea he calls the idea maze, and sort of the idea is when you have mobile phones, it's sort of like picture a person running through a maze, and there's treasure, and there's monsters, and there's all sorts of other things, and this is kind of the life of a startup, is you run in the maze, and I'm going to create the social app or something, and you run into the maze, and then you realize, oh God, no one likes this app, and I'm going to try this thing, and you're kind of running around, and then what happens is, with technology, it's particularly interesting, because then every once in a while, a new part of the maze just kind of opens up, like mobile phones, now you can do this, and it's a whole new kind of area of the maze. Our feeling is there's this very rich new maze, the blockchain maze. You can have computers that can make commitments. What can you do in this design space? And our feeling is this is an incredible new maze, and there's very few people running around that maze right now. And so we're hoping with, for example, this program to get more people to realize how exciting a maze it is and more people to run around it, because this idea that computers can make commitments is such a profound new idea. Okay, a little bit about the architecture. I won't try to pretend to explain blockchains here. Dan, I think, will talk a lot more detail, and frankly, a lot of the stuff you got to read about probably, because it's a little, if you want to get deep into it. But this is kind of very high level how I think about how one should think about a blockchain computer. On that side, if you're programming Solidity as an example or whatever you might be, in the highest level, the right level of abstraction, it just looks like a computer and it has various properties. It can do new things like, wow, a smart contract can have money in it, and things that you couldn't do in kind of previous programming languages. Here are the kind of nodes, and these, as people probably know, can be proof of work, proof of stake, and you can have all sorts of religious battles about what the right architecture there is. And then in the middle, you have a consensus mechanism. These guys are voting on the state of the machine. This one's tallying up the votes, and then the output is the resultant virtual computer, right? The short thing I'll say here is, if you think of this as a computer, I think what's exciting is that there's just a ton of cool problems to solve here, and there's a lot of opportunity for improvement. So what is Ethereum, 7 transactions a second, or something? I think it's very credible that you're going to see 1000x kind of improvements, if not more, in the next year or two on all these kinds of dimensions. So Moore's law is often thought of as just kind of packing more semiconductors onto a chip. Moore's law, actually, if you look at it, the semiconductor thing, most of it ended in 2005, and yet your mobile phone today, I bet you, is a lot better than it was in 2007. Moore's law is really about, it does matter that Intel has come up with fabrication methods to pack more semiconductors, so I'm not dismissing that. But in general, Moore's law is, I think, better thought of but more broadly as an economic principle, that when a lot of really smart people who know computer science start thinking about computer science problems and have an economic incentive to do so, those computers tend to get a lot better. And I think we're experiencing that right now around these kinds of blockchain designs. And I think that's going to unlock all sorts of new things. Because you think about like what's worked on Ethereum so far today, most of it's been things like DeFi, for those familiar with the decentralized finance, lending, things like that. Those are because decentralized finance is one of the few things that can kind of be a good, successful user experience with the constraints that a system like Ethereum has, which is it costs 10 cents, whatever it is, for transaction, and takes whatever tens of seconds to resolve a transaction. That's a great lending experience. It's not a great gaming experience, as an example. So as we see kind of better platforms come out, we should also see kind of new unlocked application design spaces unlock as well. There's a bunch of questions which I'll kind of gloss over. Maybe other people can talk about more. But what's the right incentive system for miners, validators? You have blockchain designs which rely on economic incentives. You have ones which don't. There's arguments for both. We tend to bias towards blockchain designs which have economic incentives, like Bitcoin, like Ethereum. We like those because you can reason very precisely about the economic incentives of attacking those systems, and you can assume that people are greedy and capitalistic, which and that the system will continue to run as designed, which tends to be a more robust assumption than that people are well-intentioned. And so there's a bunch of interesting problems here around node design and things, which I'll let other people talk about later. On the consensus side, there's a lot of really cool stuff happening. People adding if you've seen systems like Dfinity and Algorand, they add randomness into the consensus. There's a bunch of other, if people follow the Ethereum 2.0 stuff, there's a bunch of really interesting stuff there. There's a lot of great, really interesting stuff happening at that level, and I'll let Dan and folks talk about that. And so the way we think about it, as a result, you get these kind of trust guarantees, and then I guess kind of switching metaphors, the way I think about it is you then have the output of that are these new Lego bricks, and the Lego bricks are things like digital money. As an example, so you have on all of these sort of blockchain systems, you have these concepts of tokens, right? And you have both the kind of system level tokens like Ethereum, and you have, ERC20 type things, sort of tokens on top. You have this idea of sort of digital goods, which is NFTs, which is the idea that you can have, sort of like digital money that's non-fungible. They can represent goods, physical goods, virtual goods. I think of it as those Lego bricks then build up. You have smart contracts, which are just longer term, essentially code that runs, which then sends money or goods based on the conditions of the code. And then another obvious kind of building block that comes out of that are decentralized organizations. That's personally one of my favorite areas. I feel like it's underexplored. Decentralized. You look at like MakerDAO or a system like that. You've got to really I feel like it's dramatically underappreciated how novel something like that system is, right? It's and if you haven't read about it, I encourage you to. MakerDAO is kind of a lending platform combined with a stable coin. It's a very interesting system, but I think to me the most interesting part is a DAO. It's an organization that is owned by the token holders who then vote. In fact, there's a vote today on a major upgrade to the system. To me, this is the way that 10 years from now a social network should be, right? Instead of having a opaque, mysterious product management group at one of these large companies decide on what the rules of the U.S. election are, maybe the community who uses that network should decide on it, right? So maybe there should be a vote on Twitter or on Facebook as to what are the rules, or who are the people that represent the rules, or what are the rules around the privacy of the data? What are your protections as a user? In theory, your protections are a 30-page. I mean, think about how this ridiculous is. A 30-page privacy policy, or terms of which no one, of course, the click-through agreements, no one reads them. That's in theory how you're protected on those networks. It's a preposterous system. The right way to do it is to let users control the data, to have encryption, to have the proper governance built in. This is also, by the way, the right way to do it is to let the users own a piece of the network, right? Why shouldn't the early Uber and Lyft drivers have been rewarded along with the entrepreneurs and employees and founders and everything else as part of that network, right? But that's all enabled by these new computing primitives, which are in turn enabled by that new architecture, right? And so it's sort of you need each step along the way to kind of get to the final result. But the good news is you don't have to. you don't have to understand each level to do stuff in the space. Like, in fact, a very important thing I think will happen in the next couple of years is that specifically that you won't have to do, that you'll be able to build applications on top of these systems without understanding all this stuff, right? And in fact, that was the key moment on mobile, was that, prior to the iPhone, if you wanted to build, there were smartphones, I know people are probably too young to remember, there were smartphones before the iPhone. There's the Trio, Sidekick, the Windows mobile phone, all this stuff, but it was very, very hard to build Instagram, Snapchat, Uber, all these other things. And in fact, you had to really be like, if you wanted to do like a location-based thing, you had to be like a GPS expert, and you had to do all sorts of low-level stuff. The only real mainstream hit before the iPhone was the BlackBerry, and the BlackBerry was a hit because the founders of BlackBerry said, you know what, we're going to build a system end-to-end that's going to optimize email. And it's going to make it feel like basically a modern, like WhatsApp experience today or something. They said, we're going to do that in 2003. We're going to build a WhatsApp experience. But the way to do it back then, you had to build the device, you had to build the software, you had to build the network, you had to build everything, right? And you had to build all those things. That's the way crypto is today. Like, you want to build a killer app. Unfortunately, today, you got to understand nodes, the consensus mechanism, all this other stuff. That won't always be true. I think that we're like a couple years away from the point at which, when mobile really took off, when all you had to understand was, hey, I understand that college kids want to send ephemeral messages, and I know how to write some Swift code, and I know how to use the abstractions that Apple provided in iOS, and that's it, right? And you can just focus on what you're good at, which is like the business logic or the application logic. And that will happen, and that'll be a very important point when these two things kind of divide, and people can just think about kind of the layer that they're good at. Like, there'll be infrastructure folks who will do the infrastructure, just like there are people that are building Qualcomm or whatever who are building like the chips inside the iPhone, but then there'll be people building just applications. But I think that's the way I kind of picture it is you got these building blocks. So you've got the architecture design I was showing before, which then gives you the emergent properties of the blockchain, lets you make commitments. These commitments in turn let you create new primitives. Probably see more primitives invented in the next couple of years. I'm sure this is not an exhaustive list. And then you see like people building these sort of houses and things out of those primitives. Just a little bit about, this is more like to respond to some of the kind of cynics. We do hear a lot of, not here, but from other people, cynical stuff. People talk, about, oh, these systems are too slow, they don't scale, the user experience is bad. This is, again, something where if you've lived through different computing cycles, you remember that like the early iPhone, I got an iPhone the day it came out in 2007, and for 2 years I carried around two phones because the iPhone's connectivity was so bad, it dropped calls all the time. It was hard to type. I wrote a blog post about it. There was all these, back then, if you go read the articles, all the reviews were like, this is ridiculous. Like, how are you going to learn people are going to type with their thumbs? Like, it's now, everyone is revisionist and claims they loved it from the beginning. Actually, if you I have my first iPhone, I still have it. It's like this postage stamp. It's so tiny, and it's like so slow, and it's so junky. It's amazing how much better they got. So early PCs, the first Apple II was kind of the first PC. It cost $5,000 something in today's dollars. All you could really do was program on it. They sold 500,000 units, like that's it, Apple II, even though it's a very famous computer. But what happened, of course, is those weaknesses go away over time, right? People improve those things. So like all of these things, every one of those things goes away over time. And then on the strength side, you have these new strengths, and at first they kind of like, well, what are you going to do with GPS? What are you going to do with a portable computer in your pocket with GPS? Like, again, it sounds silly now, but that was like a real question. And it usually takes, once you have the right killer platform, I think it takes 3 to 5 years for application-level entrepreneurs to fully explore the design space and figure out what is the best thing to do with GPS, what is the best thing to do with a camera in your pocket, right? These things take a while to figure out, and you need a lot of people, a lot of smart people trying a lot of things. Is just the reality of it. And so I think a similar thing here. Like this, we're going to see over time usability and user experience and scalability. Everyone's chipping away at it. We meet people every day working on it. And then what are really the killer features with the provable trust guarantees, digital money, digital goods, all these things we were talking about? Like, what are the things? Because we've got a whole bunch of candidates right now, and maybe it's something around tokens or governance or DAOs or digital money or whatever. Maybe it's payments. Maybe it's video games. Bunch of candidates. Probably something that we talk about in this course will be something that is a killer app 10 years from now. People talk about. We don't know exactly what it is, and hopefully people like you can go and explore and maybe figure it out. A couple other things to point out. PCs, the history of that is you had Apple II in 1977, you had PCs before that. You had spreadsheets starting to be created, it was like 79-ish. If you look at the chart of PCs, they didn't really start to take off until like the early 80s. It took like 5 years. And you think about it, like now it seems obvious, well, why wouldn't you have a word processor? You want to type? Well, until you had desktop printers, which took a long time, until the late 80s, it wasn't really useful. You just sit there and type, and what do? You didn't have email, you didn't have what are you going to do with it? So these things the point is these things are ecosystems, right? Like you need all these different parts to kind of come together. And it takes time. Similar thing here. We need the regulation to be figured out. We need the wallets to be figured out. We need the exchanges to be figured out. We need the standards, the interoperability standards to be figured out. We need the new, faster systems. We just need all these different things. And so hopefully we'll chip away at it and get there. Just last thing I want to say is, I say these are computers, and that may sound weird. Is Bitcoin a computer? This is just an important distinction, is that they're sort of application-specific and general-purpose computers in general. Xbox is a computer that's made just for video games, and they decided to make a set of trade-offs for that. The BlackBerry was that. Fitbit is a good example. The Fitbit, I'm sure, I don't know what chip it's running, but it's running a general-purpose computer. It's just that they decided to optimize that whole stack for that one application. Apple took a different set of trade-offs and decided it's going to be more expensive, and et cetera, but it's going to be more general-purpose. And sometimes it's good to make the set of trade-offs for application-specific. Like I would argue Bitcoin has made the right decisions. If you want to be a global store of value, that's censorship-resistant and high security, I think they've made the right set of choices to be extremely conservative with respect to changing the system. Like I think that they've been a smart set of trade-offs. By making it more general, they would take more security risks, which would degrade the core value proposition. That's it. I'll take questions. Yeah.
So the thing that blockchains are really good for is trust. End users choose what to trust in kind of a squishy way. They don't pragmatically choose what to trust. What do you think product developers need to do to convey that to their end users?
That's a great question. It's a great question. So I think, I guess it depends on the application. I do think it will take some time. I guess I think of it like, let's take the gaming example. I think there's kind of an aha moment in gaming when you talk about like virtual goods. They haven't gotten there yet. It's just simply the products, the right products are not released yet. But to me, there will be key moments when you not only earn some virtual good, but you're then able to go really take it over to another game or sell it or do something like that. I think with most, tell me if you're like this with me. For me, the first time I transferred to Bitcoin as an example, I mean, that's technical, I know, somewhat, but it's wow, this is there's no one doing this, and it's just the network doing it. And it was kind of this magical aha moment. I think with most end users, it will probably be something, I assume, a less kind of nerdy context like that. But I do think that kind of moment, in gaming, it'll be the first time, wow, I bought this thing and I did it and no one stopped me, and I actually had the sense of ownership. I think we take it for granted. I think I sort of think of it as we just take it completely for granted in the real world that you can own stuff. And we take it for granted in the digital world you can't own stuff, right? What do you own in the digital world besides a cryptocurrency, right? A domain name. I own cdixon.org, and I like that a lot, because I have now been on so many different social media platforms over the years that changed the rules and added pop-ups and did all this other stuff. And I really like to know that I own cdixon.org. I mean, I realize this is like a legacy behavior now, and no one understands. But I think it'll come back though, because these networks always change. I wrote this blog post about it. All networks follow this S-curve. And by the way, I'm friends with people that work at some of these companies. I think they're great people. It's just the logic of the business model, right? So what happens is they follow this S-curve. They start off, and at the beginning, they're come to my platform. I'm your friend. I'll do all these nice things for you. And then it starts to grow, and then it's still good because you know what? We're growing, and everything's happy. And when a pie is growing, everyone's generous. And then it starts to get to this top of the S. Now all these networks have stopped growing, and now and then they're public companies, and they have to increase profits. With respect to social networking, we were just discussing this before I was talking. 5 years ago, saying something like owning your data, I think would have sounded really eccentric. It's like Zuko and 5 other people were saying it. I probably was saying it, but not many were. I think that's now become a relatively mainstream thing. And I think it will continue to. Those issues are those issues are going to get more dramatic, right? These issues of who gets to be on these platforms, who gets verified, what are the rules of what content is allowed, right? These issues are not going away, and they're going to get much more intense. So I think this idea, I think there's always some aha moment of wow, I own this. And I think that people will kind of start to assert their digital rights or something and like say, hey, I want to actually, like if I'm going to spend time building your network, I'd like to own some of it, right? But it's just people haven't seen this yet. And so it sounds very eccentric. I feel like it'll be just sort of obvious at some point. In the same way that in the real world, you take it for granted. Like you can go own something, and like you don't have to ask someone's permission. You know, you buy a whatever, you know, I don't know, like something for your house or something. You're allowed to give it away. You're allowed to do whatever. You're allowed to sell in the secondary market. Like why wouldn't you be? But in the digital world, we're just used to this thing where they can just change the rules and constrain you, and so. I think, I don't know, I guess, and if you talk to, I'm not a product designer, but if you talk to product designers, there's always like a magic moment in every app when you kind of, when they hook you and they see it in the numbers and they see it in the user behavior. So there'll be something like that for each of these products probably. Yeah.
So you mentioned when iOS come up with all those abstraction that you can build on top of it, especially for application. But do you see that now that all the crypto like infrastructure have a lot of team, a lot of projects are like being built, do you see that to be like a winner takes all kind of thing, and then like application developers should just trying to find a good one, or it doesn't really matter as long as they figure out how to build crypto project on top of those infrastructure?
Yeah, it's a great question. It's funny, like when I started off in the space, everyone thought like it was, you know, one network to rule them all. Bitcoin will dominate. Like one of the big interesting things with Ethereum, to me, was Ethereum had multiple important things, kind of lessons associated with it. One was, wow, it's cool that you can have a generalized programming language on a blockchain. Like that itself was cool. But then the fact that it kind of got to scale, like at least in terms of the number of miners and users, relatively quickly, it was like, wow, maybe there can be more than one network. Like that was to me a kind of an interesting moment. I think it's a great question. I think we're really early for like having like a winner yet. We don't even know where the winner is. I also think there's a kind of a cool potential future where you have blockchains interoperate. I would love to see that. Like I would think it'd be really, like if you guys know like TBTC, the TBTC is like this kind of way to custody Bitcoin on Ethereum. Like, and then you could have Bitcoin, you get, like in my ideal world, you have, Bitcoin is a true kind of store of value, just sort of 20 years from now, everyone thinks of it as like the digital gold, and it's, of course, it has value and it maintains a value. And then it's then custodied on like something like Ethereum, which can then be used as collateral for like stablecoin, which maybe Ethereum is just the collateralization platform, but then you have like a cross-chain interaction onto a high-speed payment sidechain, and you can imagine like this really like elegant kind of fabric, which is actually kind of how the internet is, And the internet, like, Ali just wrote this nice tweet storm about the history of IP. IP was kind of, if you look back, it was just kind of this really kind of basic protocol, and had competitors that were much more feature-rich, had better security properties and quality of service properties and things like that. But it ended up, and for years, you go back and Google, like, all these people, I won't name names, but in the 90s, all these people were like, oh my God, we're going to run out of IP addresses, the internet's going to break. It was like all this stuff. And then what kept happening is like, DHCP came along, and, and I don't know, like DNS subdomains, and just like all these different like things hacked, and then CDNs, like Akamai, like, oh, it's going to break, but then, kept layering these kind of different things on, none of which were like totally beautiful and elegant computer science ideas, but they were pragmatic and they worked. And if you actually look at the internet today, it's much more of kind of this tapestry of all these different systems put together with this one unifying interoperability layer of IP. And it works very well that way. And so you can imagine sort of an equivalent thing with the Internet of Value, sort of all these different things and each one doing kind of what it's best at. That would be the most elegant thing, and we're pretty far from it. Although we're not, like we're far and we're not far. Like some of these things are like, could happen in the next year. And so that's a great question. That's something we actually debate a lot. I don't have an answer. I mean, it's a really interesting question. Yeah. So,
as a startup founder, how do I think about decentralization?
It's kind of a loaded question. Well, I think decentralizing your own startup?
Yes.
This is one of these things where I think there's an emerging playbook, like what Jesse alluded to earlier. And this is one of the reasons we want to do this thing, because I feel like there's now best practices starting that aren't fully propagated out into the world. Great question. Like in an ideal world, here's how a crypto startup works, I think, is you start off and you're kind of more like a regular company. Maybe you're physically located together, maybe you're partly remote, but you're working, on like a regular kind of project management schedule, and you have, like you have a repo and all this other stuff, right? And because that's probably how most, just from a practical point of view, how you kind of get software off the ground. And maybe you have like a Delaware C Corp and like a traditional corporate structure. Maybe you have stock options and whatever. But then over time, ideally, you become like Bitcoin or something, right? Where it's just like, it's a network and it's just part of the internet. You've just added, that's what's so cool, is you've added a new feature to the internet. The internet can now do lending. The internet can now do ride sharing, and it's just like part of the internet. And of course, you should be financially rewarded. The investors should be, but you do it through the individuals, right? The individuals get some distribution of tokens. Those tokens, you go off and you're living in wherever in Hawaii and you're hacking on your open source thing and you have your tokens and like it's all, and like you may or may not, like you may jump in and out, a lot like the open source world, like today I'm working on Linux, tomorrow I'm working on Apache, whatever, and you maybe own some tokens in each, and like that should be the way it is ultimately. But I think what we're seeing now, these people start off kind of more conventional, but then they do kind of progressive decentralization, is what people are calling it. And there actually is kind of a whole kind of thinking around both the corporate structure, the regulatory structure, the kind of architecture of the systems, how you govern those networks. Not all the problems are solved, but a lot of them, I think, are a lot farther than we were a couple of years ago. And I don't know, I think that's like kind of the really exciting vision. And I think if it works, that's just the new way startups are created. Like that's just how you do internet startups, right? You have or at least network-based startups that involve networks, right? That you'd create it as a protocol, and you'd have tokens, and you'd start off together, and you'd have like more like a traditional cap table, and then over time you just kind of disperse the tokens, and the users would have some, and the developers would have some, and people would come in and out of the community. So, but we'll get into more details throughout the course. Yeah, I think.
So we're going to do one more question.
Sorry. Yeah.
Can you talk a little bit about the future of identity versus anonymity on the blockchain?
That's a good. Identity is like the most. It's like the most overloaded, term in technology. It can mean so many. It's just it's a very complicated. It can mean a lot of different things. Do you mean real world identity? Yeah, so real world, I think there is so one of the constraints right now when you design blockchain applications is you have to assume you don't have real world identity, which means you have to assume you don't have sort of repeat players in a game. And so you kind of have to assume the worst case. So you think about like how Compound, like a lending platform works. You just have to assume everyone's evil, you don't know who they are, therefore they have to over collateralize. Like if you had identity, you could assume they're repeat players, and therefore you could do things like credit scores or sort of assign reputation, like it would relax the design constraints a lot. I think if you talk to a lot of these protocol designers, so I think it's an important thing. I think in an ideal world, it's probably like these standards that people are developing where it's kind of opt-in and facet-based. So opt-in meaning you choose when you want to reveal your identity, and you can choose not to. So the user has the power over that, right? And I think. And then the facet-based meaning I can reveal my credit identity facet today, or I can reveal my educational facet, or I can do whatever. I mean, to me, that's the most user-empowering way to do it, and the right way to do it. Getting here to there. I mean, the thing is, like, identity is not an application. Someone has to create an application that's sort of that drives usage and demand for these things. And so there's a lot of interesting thinking going on around it. I don't know what the actual kind of startup is that kind of drives this forward. But it's a great topic, yeah. Okay.
Great.
I think we got to
so we're going to wrap up. If you guys have more questions, we encourage you to share them on the Slack channel.
Yeah.
Thanks, Chris,
for
the presentation.